we discussed this paradox in our last class that acceleration can take the sign negative also if the velocity itself is minus.
Okay. Okay, understood, sir.
So if we get a connection, sign changes in a U-turn motion. So we are making a case. First, you copy this. A ball is thrown upward. Later, it falls down.
Done, sir.
Now, this is a situation. Copy this screen.
But sir, isn't like the acceleration increasing when like the kinetic energy of the ball increases as it falls down more?
Look, this is a good question. Acceleration is not directly connected with kinetic energy. Acceleration take everything from velocity. If velocity is increasing by the same number, acceleration would be constant. If velocity is increasing on different numbers, then acceleration would be different. Actually, acceleration is a derivative of velocity. The kinetic energy directly affect velocity. So acceleration, increase, decrease was we just discussed 5 cases. These 5 cases are actually belonging to this idea.
Okay, sir, you'll explain more, yeah?
Sorry?
You'll explain more, yeah?
If you have, let me know once you people have copied it.
Okay. Done, sir.
Okay. This is, this is something we discussed in our last class. It's a paradox to understand that acceleration is negative throughout if it is a U-turn motion. It's in one go if it is going upward and coming down. So when it is going upward, remember, look at this carefully, this important thing, look at carefully. Velocity is plus, but velocity is decreasing. So acceleration will be negative. Why acceleration is negative? Because velocity is decreasing. When you're coming down, velocity is negative, but velocity is increasing. Logically, increasing velocity should be positive acceleration, but velocity itself is negative, which makes acceleration negative. So this is a paradox. This is a mixed concept, and it is giving us the idea that it is possible that acceleration can take a negative sign even though acceleration is not retardation. It is a positive or negative is only a sign coming from plus minus v.
Okay.
Look, this concept again, this is also a very important concept. At the highest point, velocity is zero and acceleration is maximum.
Okay, sir. So basically it's negative to the entire thing, and zero is the highest.
If it's a U-turn motion, but at the highest point, the object stops. At the highest point, the object stops for a second, then velocity becomes zero, but acceleration is maximum because the object is taking a U-turn. Another important concept, displacement changes the sign when you cross the level. Displacement changes the sign when you cross the level. So displacement changes the sign. Displacement changes the sign when you cross the level of the cliff. Acceleration exists throughout the motion. Acceleration exists throughout the motion. Now, when velocity is zero, acceleration is max. When velocity is max, acceleration is zero. When velocity is minimum, acceleration is zero. You have to copy this.
So how is acceleration zero?
Look, make a concept like what is acceleration? Acceleration is the rate of change of velocity.
Yeah.
Acceleration is the rate of change of velocity. So when velocity is maximum, it is a constant value. When it is constant, there is no change, so acceleration becomes zero. Suppose you are driving a car and you reach the maximum speed. Okay, the car has reached the maximum speed, no further change can occur. When velocity can't change, acceleration would become zero. So this is a series of tricky concepts. You copy this screen.
Okay. So basically, when velocity is at its max, yeah, and there's no change, acceleration is zero, and velocity is at its minimum, and there's no change, it's zero as well, because there's no change of velocity.
Good. It is like a number game, na? When you say minimum, you can't change it anymore. When you say maximum, you can't change it. When you cannot change velocity, it means acceleration has become zero. Now look
Okay.
at this example to understand how plus minus situation works here. You have to copy this example and try to solve it. You have to copy this example and solve it. I'm just coming. I have to say Maghrib Namaz and please solve it and I'm just coming.
Okay.
Look at this working and check the answer.
So the acceleration is for average acceleration, yeah.
This is an average acceleration.
Yeah. Done, sir.
Calculation of acceleration. We know this formula can always help us to calculate acceleration. This is the basics, like an object is moving and a car is moving from rest 0 meter per second to 30 over a time of 8 seconds. So we can put the data, like this, and we can calculate the acceleration using this formula. Now comes the title topic, the very important, the main core topic of this chapter, equations of motion. So now you have to give this heading.
Done, sir.
Now, these are the equations which are applied for objects moving in a straight line. So these equations we are using. S is representing displacement, U initial velocity, V final velocity, A acceleration, and T time. Now, these are the equations to learn. You have to copy this screen.
Answer.
1 second, sir. Done, sir.
Now, these equations are valid if acceleration is uniform. This is a very technical issue. All accelerations are not uniform. All accelerations are not uniform. In our normal life, when we move, our velocity changes randomly. Sometimes it increases by 4, sometimes it increases by 2. So it increases randomly. This is called non-uniform acceleration. So these equations have a limited application when acceleration is uniform. Secondly, motion is linear and the object is rigid. Rigid means it does not deform during the motion. These are assumptions of the equations in order to apply them. So you have to copy this screen.
Done, sir.
So these are three assumptions. These are the three assumptions when you want to check the validity of these equations. Now we are moving towards our next title. It is called vertical motion. Vertical motion was in our O level also, but numericals were not there. You will find a huge difference between O level and A level numericals. The level is huge and different. And you must have heard about the latest results, which are A level in the now it's a worldwide news that A level results were quite pathetic. Many people are upset. Even at Excel, people were not happy. So the results were very challenging. So this is actually why, because the core issue is the past paper, topical past paper. So I think if you should try to get the books, let me know once you are able to get the books. Meanwhile, I will try to post some digital books to start with. Now
Sir,
give the heading. Yes, please go ahead,
we're
sir.
gonna get we're gonna get the past papers tomorrow. I think so.
Okay, very good. Are you getting it from the same area or you're getting from Pakistan?
No, from school. School. They'll give us
Ah, right, right. But you told me the schools are going to open on 28th.
yeah, like our school they started like a week earlier for people in grade
Okay,
11. Yeah, but like properly they'll start in like 28.
good. So now give the heading vertical motion. There are two types of vertical motion: motion without air resistance and motion with air resistance. Copy this.
Done, sir.
Done, sir.
Motion without air resistance, it is also called free fall, and motion with air resistance. I'm starting with free fall. Free fall means acceleration is equal to G. Free fall means either air resistance is not there at all, or it is there, but it is not considerable. You have to copy this screen.
Done, sir.
So when something is falling without air resistance, it is only due to gravity. In free fall, weight is the driving force. This is called free fall. So free fall means no other force is there. Free fall occurs at a constant acceleration. In O level, it was normally 10, but in A level, they make it 9.8 meter per second square as the value of G. If I take it 10 for understanding purpose, what's the meaning of this 10? The 10 means that in the velocity increases, the 10 means that the velocity increases by 10 in every 1 second. The velocity increases by 10 in every 1 second. This is a type of understanding that when you say acceleration, when you say acceleration as 10, what it means that if you drop something in a free fall situation, its velocity will increase by 10 in every 1 second. So after giving the heading, write under it that in free fall, weight is the driving force. In free fall, weight is the driving force. In our course, we take this value as 9.8. And as mentioned that it is near the surface of the earth. Now the surface of the earth is a major issue because the value of G changes. The value of G changes as you move away from the earth. So that is why they always put a condition. They always put a condition that the value of G is taken to be 9.8 only when you are near the surface of the earth. In O level, normally we use this value as 10. So here we have a change. So now you have to copy this screen.
Done, sir.
Done, sir.
So when you say, I'm just taking assumption 10, it means that the speed will increase by 10 in every 1 second. In our course, G has two possible translations. When something is falling, G means acceleration due to gravity. When something is falling, G means acceleration due to gravity, but something is not falling. We are sitting in a class. So for us, G means gravitational field strength. So G has two possible meanings. You have to copy this screen.
Done, sir.
Done, sir.
Now, according to this, G has two possible units, ms minus 2 and then Newton per kg. This is where physics is a very interesting subject, that the same value, but the unit is different. So when unit is different, it will mean differently. 9.8 ms minus 2, 9.8 ms minus 2 means that in every 1 second, velocity will increase by 9.8, and 9.8 Newton per kg. 9.8 Newton per kg means 9.8 Newton per kg means that on 1 kg mass, the Earth will apply a force of 9.8. So this is the meaning of the term. This is the meaning of the term. When you change the unit, it means that. So now you have to copy this screen.
Done, sir.
Riva, have you done it?
Yes, sir.
ms minus 2 is equivalent to Newton per kg, and it can be proved by that from the unitary method using base units. Then you have to copy this screen.
Done,
Done,
sir.
sir.
Now, a famous example is there again, that if a feather and a stone are falling together without air resistance, they will accelerate by the same value. Why? Because normally feather comes slowly because of air resistance on it. But our theory now says that if there is no air resistance, feather and a stone will fall down with the same acceleration. You have to copy this all-time famous example.
Done, sir.
Done, sir.
When you talk about mass, it is ideal to remember that mass is always focused towards the center of the source object. Normally in O level, we had a concept that mass weight is always acting downward, but mass always concentrate towards the center of the source mass. Now, calculations involving acceleration due to gravity. You have to give this heading. I'm just coming, give this heading.
Done, sir.
Rule number one, velocity is decreasing. If object is going upward, acceleration is negative g. You have to copy this screen.
So how is velocity acceleration negative g?
Because it's going upward, velocity decreasing. Whenever velocity decreases, acceleration is actually deceleration.
Yeah.
And it is negative because negative sign is valid here because velocity itself is positive. It's a
So
game
it's
of
not
direction.
so it's not going in the direction of g. Instead it's
No,
going the
no. It is coming from decreasing. It's coming from the word decreasing. G is getting a negative sign because velocity is decreasing.
okay.
So it's a paradox. It's a very confusing in the start. Plus minus of velocity and plus minus of acceleration are always different in nature.
Done, sir.
Sal, you have copied it?
Yes, sir.
Now, velocity is increasing. It's a downward motion. And remember, air resistance is not present.
Done, sir.
Done, sir.
Now, it's a famous U-turn motion. In a U-turn motion, velocity is zero at the highest point. when it is going upward, velocity is positive, and when it is coming downward, velocity is negative. Here the velocity is plus, here the velocity is negative. For the upward motion, velocity is decreasing. And for the downward motion, velocity is increasing. Overall, G will remain negative. You have to copy this U-turn example.
Sir, this is the same as U-turn, yeah?
This is U-turn. This is typically a U-turn.
Okay.
Done, sir.
Done, sir.
For maximum height, take final velocity 0. When examiner talks about maximum height, take the final velocity 0. Rule number 5, when the object goes up and comes down, the resultant displacement is 0. So when the object goes up, comes down, and it is on the same position, U-turn example, resultant displacement would be 0.
Done, sir.
Done, sir.
Now this comes again, we have already copied it. This is a complete diagrammatic concepts of all the concepts we discussed here. Rule number 6. I'm sorry. Time to reach maximum height is the time to reach the ground. It means if it takes 2 seconds to go up, it will take 2 seconds to come down, provided there is no air resistance. Okay, have you copied it, done?
Yes, sir.
So it means that if air resistance is not there, it is a concept of time bound. So if it takes, suppose, if it takes 2 seconds to reach the maximum height, it will take the same time. It will take the same amount of time for the descent. So for example, it takes 2 seconds to go up. Then it will take 2 seconds to come down. This is a hypothesis when there is no air resistance. Use the same equations of motion, but replace A by G and S by H. It is only a formal way, it is only a symbolic way to impress the examiner that you should change the letters A by G and S by H when you're talking about vertical motion. You have to copy this.
So what does AGSH mean?
A for acceleration, you know that's why I'm
Okay.
inverted the conventional letters.
S is distance and H is height.
Sorry, can you repeat?
Is S distance and H height?
S is distance, definitely, and H is height.
Okay.
Done, sir.
So these are the equations in which you have to change the letter. Now give the new heading, determination of G.
Done, sir.
This is a design topic. You people might remember this word, design topic, in our O level. If you have done obviously GCSE, and you might remember the paper 6. In paper 6, there used to be a question that you have to design an experiment. And what is that designing means? That you have to make a way how to find something. So this is a design topic. So make it there, design topic at this point also.
Okay. Done, sir.
Now I'm using an indirect approach. Give us side heading, indirect approach.
Done, sir.
This is an indirect approach. This is a simple pendulum. And if you want to find G, we can use a simple pendulum. And this is a formula. The indirect approach means that if you want to find a value, you can use any formula which examiner will give actually, which formula can be rearranged. The formula can be rearranged to find the value of G. So this will be called as an indirect approach. Indirect approach means formula approach. Indirect approach means formula approach. And you do not go for any actual lab work to go for a free fall. So we stop here, and we will inshallah continue this in our next class.
Okay, sir.
stop here and we will inshallah continue in our next class. Thank you. Allah Hafiz.
No, please.